Nice. Okay, so welcome to building awesome Azure function apps. What did you think that was? So management has not picked up on that at all yet. You'll find out when I'm fired.
I was going to do the same thing yesterday.
Engineering Center A to F. Most engineering place you'll see. That's what that says. It's a little light with the lights on it. So tonight, all about Azure functions. Anybody doing Azure functions yet? Oh, you could go home. So give a little overview. Once we're done here, you should be able to start at least building some Azure functions. You should be able to leverage your existing .NET skills to do so. And we'll see, what the brouhaha is all about with Azure functions, what you can do with them, a few samples, and hopefully you can go out and start building some awesome AF apps. Right? So, what are Azure functions? This might be a little anticlimactic, but it's code, right? I know, shocking starter. Events and data. So this suspiciously looks like all of your programming to date so far, doesn't it? Right? Code, events, data, you put them together, and we paid an entire department to do that. Animation and logo at Microsoft. That's what you get, the Azure functions. And that's kind of it in a way. We're going to see how you take kind of a programming 101 concept, the concept of a function, which is the most basic thing in programming, and how we're going to take that and we're going to cloud enable it, which gives us a lot of great things, even past a resume buzzword, right? And putting cloud enabled on it. So we'll put it in the cloud, and instead of just having it work like a plain old programming 101, kind of basic function that you would find in any old language, what we'll do is we're going to supercharge it while it's in the cloud so it can do things like glue your enterprise systems together and code or run batch processes or do other businessy things for you. That would have otherwise been a bit of a pain to do, things that you've been doing, but that you might have some overhead and a little bit of friction to get done before. So we'll see how that does that. So, what's our function? Back to your first days of programming. It's a unit of work, right? It just does stuff. Executes, starts, and finishes. Often they have inputs and outputs. Generally in .NET you can have multiple inputs, right, or parameters or arguments, and you can have a single output for, say, C# or VB.NET or something like that. We still have VB people here that will admit it? Not a one. I know you're out there. Yeah. So inputs and outputs. The cool thing with Azure functions, outputs. So you can actually have multiple outputs, and these outputs are where the supercharging comes into play. So instead of just returning a value to some other function, we'll see how that return can actually hook up systems together, which is where it really shines. First off, of course, the obligatory mention of how Microsoft loves open source more than anything else in the world except for Linux. Right? So this is all open source, Azure functions. It came from the Azure Web Jobs SDK. So you'll see if you go to github.com/Azure, you'll see references to web jobs. And then once in a while when you're working with functions, you might see the word web jobs. So that's where the base of the code came from. Web jobs were out there helping us supplement some of our ASP.NET programming or other kind of programming. And now that we have functions, it's kind of grown and matured into its own framework. But we just didn't get around to renaming everything yet. So that's where you could get the source for Azure functions. Now some examples of what we might do. with Azure Functions. Everything that you already do, you can do with Azure Functions. Some things will lend themselves to be better candidates for an Azure Functions app than others. So we'll take a look at these examples. Timer-based stuff. How much code do you have in various companies? Think of everywhere that you worked as a programmer, where you wrote some modules, or maybe a console app, a Windows service, Windows Forms app, any kind of app, doesn't matter. But you wrote this program, and then you have to go and schedule it. Maybe even just SQL queries, right? To move data between systems, or to convert text files into SQL, or any kind of batch processing. Stuff like transforming CSVs, that's a popular one, to SQL, to blobs, to some other kind of data. Moving data back and forth. You might have like an SAP system, and then a CRM system, and you need to stitch them together. So you write a program, and it moves the data back and forth. Maybe it calls APIs from those different programs, or maybe it just hits the database directly. It doesn't matter. But those things we do, and we put them on a timer. Along with batch jobs, right? Everybody has batch processing that you have to do every week or 2 weeks, or whenever, maybe payroll. That's our most important batch job that we have to make sure gets done, right? Got to pay the programmers for our beer on Friday, right? So those kind of things. So here's a few examples to stream processing, or nowadays, not so much legacy, but bot messaging, things like that are becoming more standard for companies with customer service fronts. Anymore, if you go to like Delta for the airlines, or anything that has customer service where a little window pops up and it appears to be a humanoid thing in there talking to you. It might be, but it might be a bot. Right? I'm pretty sure I always get the bot, because it can never seem to help. But we could program that. Things like CRM, customer relationship management, and anything from Microsoft or non-Microsoft. So lots of great things you could do. Anything that you have software for that you need to stitch together, you can do that with functions. And it'll take away a lot of the legwork that we shouldn't have to worry about as developers, and a lot of that sysadmin stuff that comes along with it. Some of the real world scenarios that people are using. We have some interesting things out there. One of them is tracking. Lots of vehicle and package tracking. So we have competitors to FedEx and UPS and DHL. There's small courier services and some of those larger ones that are tracking both their vehicles and the packages. And some, like vehicles, things not Uber particularly, but some of those types of services. As items move through space, and they're either scanned or hit some kind of a checkpoint, maybe an RFID checkpoint or something, that little piece of data or information about what's happening with that package gets sent to an Azure function. The function processes it and then goes away, and then it's in the system. Then later, another Azure function might show up to take that data and copy it or transform it into another system for the next step in the business logic. Data cleanup. So who's going to admit to this one? You have that database, right? It's always the other person did it too, right? A database, and it's supposed to be normalized, but you get phantom data in there or some dirty data, right? And it's always the person who quit, right? That person did that terrible thing, right? Can we blame them for at least 3 years after they quit for doing this? But you have to deal with it, so you have to write a little SQL script or console app to go in every night and clean up after their BS, right? Because they didn't know how to program, or they didn't know how to structure a database properly. That terrible programmer. So that kind of stuff, it happens everywhere, right? We don't get systems perfect on the same all the time. As a matter of fact, I would argue the opposite. Developers ruin more systems than they make good, I would say, very often from going around to different companies and seeing what's out there. It's a little scary sometimes. But you have to deal with that. So sometimes you have to deal with dirty or phantom data and you have to clean it up. So it's a batch job. That kind of stuff is happening with Azure Functions all over the place, going and cleaning up that data. Very often you can't just go and set a constraint on the database because that will break a whole bunch of other systems. So until you can get to that point, we have functions to help us with that as opposed to your own little app. Edit, transform, and load, right? That's your classic, run a batch job every night to move data between platforms. IoT now is becoming, those are legacy, some of those kind of processing. Newer stuff, IoT, because we want to internet everything. When I wake up and ping the toaster, make sure it knows that I'm there and I know it's there. And internet enable my refrigerator and everything else, right? It seems, especially Amazon loves this kind of stuff, right? Little buttons for you to order everything. It's like crack, right? Oh, I want more of this, I want more of that. And so IoT solutions. Some of the ones that our actual clients are using around Washington, D.C. in the U.S. Washington gets snow. They don't get a lot of snow, not like you do here, right? You do get snow here, I've heard, right? So, and they do, but it's not much. And when they do, it goes into complete panic. You should see how people in the U.S. in the South panic over the snow. It's hilarious. Oh, you're a Southern person?
Virginia.
Oh, you panic then.
It's great. Like school's closed for a week.
I know. And I come from Pennsylvania, so like 3 feet of snow, we're like right through it. It doesn't matter. Yeah, we don't care. But you go to the South, and I'm like, oh, you people, I get the road all to myself because there's an inch out here. Yeah. So snow depth monitor. So they actually put down sensors on some of the roads. And then they could say, look, snow is falling a little bit heavier here. We didn't clean it up fast enough. So what happens, they have functions processing that now to the traffic reporting systems so that you can see, your GPS can take you on an alternate route where there's far less panic now. So you're missing the good stuff now, right? Where you can go. So then everybody goes over there instead and panics over there. So panicking over here. If you like sports ball, right? This more sporting stuff. Lots of IoT with sports. So we have this sport where we take a brown egg and we give it to a man, and then other men jump on this man and hurt him. I don't understand this myself, but apparently this is very popular. And this can be dangerous. Apparently they get a lot of head injuries from this, which makes them then return and play more. When they do that, we need to monitor those hits and see exactly, what kind of health impact is that. Did they get a concussion? Was that hard enough for that kind of hit in their helmet? Are their bones maybe getting close to a point where it might break, or something that's really strenuous? So now there are sensors in the sports ball, like I call it hand egg, because that's what it is, right? A little hand egg. So now we have sensors that can tell you, somebody took a big hit. Maybe they shouldn't continue playing, or they're risking a really bad injury. So we can then monitor and get that to the doctors very quick. That information goes to the coaches' iPads or Surfaces, and then Azure Functions processes it to get that information to the sports doctors, and then they can work with the players that way. Yeah. Sports ball, yeah. Same thing with stick puck. That's the Canadian golfing on ice, right? That thing too. So Canadian ice golfing, the same thing, right? Because they also take a lot of hits. Right to the head with the stick, and then they want to go back and get more of that. So, internet traffic, so not just actual car and vehicle traffic. Here's the company you go to, lots of companies, and they monitor your internet, and they want to see if you're spending too much time on Facebook. Well, yes, we're all spending too much time on Facebook or Twitter, or if you're hitting the naughty sites or whatever it is that you're not supposed to be doing, or maybe what you are supposed to be doing. Is the accounting department constantly Googling for this particular tool or technique? Well, maybe we need more training for them, or to buy them that tool, like a calculator or whatever they use, their accountant, I don't know. So that kind of stuff. Internet traffic aggregation. So there's a company in the UK called SensorNet that has some of the world's leading companies, like McDonald's, yes, the food of my people, right? So, McDonald's is one. I think Boeing is another. Like and they provide this software for huge companies that monitor. I still don't know what people at McDonald's are using the internet for, but okay, whatever. But they're not going to naughty sites, I guess. Anyway, we're talking tens and hundreds of millions of executions per day. Right? So these are big companies. So they are using a lot of internet traffic, and that traffic is being posted through Azure Functions and then aggregated so that their management can take that data and then either, I don't know, yell at their employees, get off of Facebook, or say, look, we see these patterns of activity, maybe we can adjust our business to make it more efficient. So that sort of thing. Now, with Azure Function apps, we'll see that a function app, you can build a whole app, and this app can be as small as one single function, or it could be multiple functions. And where functions shines are these examples I've been giving you. Data processing, right, all that moving of data around and batches and all of that. Another one is microservices and serverless architecture. Also, great buzzwords for your resume, right? Stick that on there, impress the next boss to be, right, with those kind of things. So we can actually take these and break down our architecture a little bit differently to make it more modern and hopefully more efficient. Executable stuff, stuff that doesn't necessarily have to be RESTful. And of course, integration is a huge one, right? And that's something every company wants. You have all these different systems. Some are built in-house, some you've purchased, some are Microsoft or Oracle products, or a big tech company product, and we need those things to talk to each other. So we want accounting to talk to payroll so I can get paid on time, and I know that I'll be able to because we know how much money is in the bank in accounting. So those sorts of things. So Function Apps is great for that workhorse back-end stuff. Excellent for that. Now we also have API apps. Now you can build just a flat-out API with Azure Functions, but I wouldn't. We have ASP.NET Web API, which kind of does that already, and it does it well. That's what it's for. So if I wanted to do something like forms over data, CRUD operations, we'd probably go with an API app with maybe an MVC front end or something like that, or maybe even a mobile front end is fine. If you need that API architecture, or if you're just serving data to a variety of clients, maybe mobile, maybe web, maybe even some other system that's just consuming some JSON data, that sort of thing, you could just stick with an API app. All right, so not everything is like the perfect, functions aren't the perfect solution for everything. They do really well with everything on the left. Stuff on the right, you can do it. It'll be okay. But Web API is probably better, or a more traditional approach. We generally don't do integration with APIs. I've seen it though, people will. fit the square peg in the round hole. Leave it to a programmer. They tend to do that. Also, if you have the restful purist, that very religious person about rest, that insists everything be as restful as possible, go with an API app, right? Or you'll just make them, you'll put them into a depression, it'll be awful. So API apps has a place as well in standard apps. So we don't want to just go moving everything to functions, but many, many things will be fitting in there well. So this is all about serverless computing. And I do have a little news about that. We have lied. There are servers. There are servers. It's just that you don't have to deal with them. As a programmer, I want to run code, not computers. I've been around this business for a few decades. Yes, a few. I remember having to do things like installing drivers and firmware. We don't have to do that so much anymore. I bought a Surface, and I did not have to install any firmware on it or update a video driver or put a network card in it or any of that stuff. It just magically worked. I remember a time when we had to do that, and you had to be more close to the hardware as a programmer. And when you're doing that, you're not solving a business problem. You're solving a get through this hardware issue, right? That's what you're solving at that time. And while you're solving that, the business problem is still sitting there waiting for you to get to it. But you can't get to it because you have to solve this other problem first, the problem of infrastructure. Now, this is why companies like Microsoft exist, right? We supply that infrastructure code for you and the platforms for you so that you can focus on solving a business problem as opposed to these other kind of problems, right? The problem of programming itself or having to deal with sysadmin stuff or those kind of things. So we want to just run code as opposed to the computers. If you want to run the computers, maybe IT Pro stuff is for you, right? That's what they tend to do. And even that, they're getting lazy, yeah. And so they're going cloud-enabled, right? Don't have as much legwork to do as well. And there are certain things like security and whatnot. I feel a little bit better with a nice service agreement and letting, if I were a client, letting Microsoft patch it for me, right? And then they would take the responsibility for that. And I don't have to, right? Ask Equifax about that one. Yeah, I think somehow I don't think they're actually learning their lesson, but they should be. But other people are, so that's good. So serverless, the big deal with serverless is PaaS or platform as a service. So I'm all about this, right? Having the server patched for you automatically and scaling for you and all of those kind of things that I don't want to worry about because I want to deal with the business problem. So that's what serverless is all about, right? Microservices gives us a nice architecture to work in the serverless space, but we want that platform. Think of it historically, when you would build an application. I remember the days, even before .NET, you would build an application, you would have to purchase a third-party utility to run it through, and then you would have to build another app to package your app, and we didn't even call them apps, we still called them programs at that time. Right? And then you would have to package that up and then deploy it to the various systems. And it was kind of a nightmare. And then the boss would always make you do it on Friday because they're just evil like that. And then you're stuck there all weekend. Now, all of that stuff is done for us. We could push a button and do, just a few clicks to deploy or publish stuff up to the cloud. And another thing that I don't have to worry about is working with an IT pro. Yeah. So, I go and I write this program and I want to deploy it and I say, here, I want to put it on this server in-house. And the IT pro, your sysadmin says, no. All right, and you say, all right, well, how about I do? No. Maybe, no. And that's all you hear, right, from the sysadmin. No, you can't do that. All right, or you have to wait. And some corporations I've seen, they just have all this red tape to get something deployed. You have to fill out forms and ask for permission and say, well, here's what I'm doing, and will we have the proper security, and all this kind of stuff that might go with that. This takes away a lot of that, which actually helps the sysadmins do their job, right? They could focus on making sure that they're maybe doing penetration testing rather than just patching servers on Tuesday, things like that. So we can have the platform for us and taken care of for us. That makes it also one of the things that is taken care of for us is stateless scalability, right? So auto scaling, right? So I don't have to worry about deploying to a web farm. I can just deploy to the cloud and we're good. Things that are great for serverless computing too is a sporadic workload. We do have this, right? If you have something that only runs once every quarter or year, or just kind of once in a while, maybe there's a special event going on, a summer festival or a festival, and it just kind of happens whenever. Well, the whole rest of the year, that software is sitting there, maybe software that's similar to Eventbrite or some kind of event sign-up software, sitting there all year and nobody's using it, right, for this particular festival. And then, all of a sudden, with a few weeks leading up to the festival, people want to register for that festival. So then all of a sudden, the software has to be up and running. Well, even though we're only using that software for a short amount of time, the sysadmin does still have to patch that machine, and they have to make sure it's secure and keep it up to date and all that other stuff. So you waste resources on the rest of the time when you're not using the software, right? And that's just a waste. If we have things in Azure, not even necessarily functions, but other Azure items as well, or other Azure services, you can have stuff sitting up there. Hey, Microsoft people are doing the patching for you. Your sysadmin doesn't have to deal with that. Right? So that kind of thing. So sporadic workload is great for that too, plus the scaling. Right? You go from not really much use to a whole bunch of use in a short time. So that ramp up, you need the resources for it, and you will have that with Azure. Right? Serverless tends to do stuff rather than just be an API returning data. And it's all driven by events. And so we can orchestrate how these events work and how these processes get kicked off. Serverless code tends to be microservice architecture, but it doesn't have to be. The cool thing about doing it in functions is that you get a variety of languages, all kind of stuff. C#, of course, and F#. No VB. Sorry guys. Node, Python, PHP, Batch. There's even a few more that I didn't even put on the slide yet. So you get a whole bunch. You can mix and match within a single app, right? So we like to do that. Also, with this code, we'll see that one of those ways to do events is through exposing HTTP endpoints. And we often have little calls coming from some location that might want to kick off something. Okay. The scenarios for these patterns, of course, you need scalability and, of course, statelessness, the nature of the web. The next 2 points are the most fun. Right? Stuff that's like way too complicated for a traditional project structure, but stuff that is way too simple for a traditional project structure. So you have think of your ASP.NET web app. You make an MVC web app. Maybe it sits on top of an API, and it does forms over data. That's pretty standard. Okay, that's just your app. That does not need to be ported to Azure Functions, right? It's kind of in the middle there. You're good. But little tiny stuff, that console app with not a lot of code in it, just a little bit of code, but it actually does something important. Sometimes little bits of code actually do things important, like whatever code was behind Control-Alt-Delete. Kind of important. Not a lot. It just says shut down, right? So that kind of stuff. Often, I find those little snips like that in all the strangest places. I've seen Access databases doing that. Oh, God, yeah. Excel, like Office, people programming Office stuff to do that. Little console apps. Often you'll have an office and there's a little machine sitting in the corner and has like 3 inches of dust on it because it just has a console app running all day and it just moves data from one database to another. Tiny little thing, but that data that's getting moved, even a few rows, is really important. But nobody wants to touch that machine because whoever wrote those little bits of code is gone. And you know, if you touch it, you're going to hose everything, right? And this, I see this in company after company has this machine that nobody wants. It's like it's got a demon in it. Nobody wants to go near this thing. So much so, I had a client once with a Novell server like that, and when they moved about a kilometer away, they realized that this machine was in the closet. They forgot that they had this machine there, and after they moved, they were like, oh crap, what happened to this program? Oh, it's in the closet. And then they didn't have the password for it. So they actually took it and the UPS, the battery backup, and they actually had a couple of people put it on like one of those dolly things, those little hand trucks, and they actually kind of trucked it down with the UPS connected to the next office that they moved to. Like, that's the kind of stuff that is out there. So the cloud would solve this issue for them. Very much so. Also, Novell, when's the last time you heard of that, right? Running anything. So, of course, there was no password. If you have lots of services involved, right, writing a traditional app, right, file new project, WinForms, console, web, trying to hit all these different programs, a SQL connection to this, an Oracle connection to that, all the NuGets or references and APIs you have to hit is quite a bit to maintain in an application as well. Another one is, your human involvement, that machine. Human involvement needs to stay low, right? You just want to put the software out there, let it go, and not have to worry about it. And this is like why I programmed to begin with, not having to deal with the humans, just dealing with the computers. So those are some of our scenarios for serverless. And of course, that gives us all those benefits I've been talking about. Right? You could focus on your business problems. Deployment's not a big issue anymore. And of course, it's cross-platform as well and lightweight. So for Azure Functions in particular, here's our obligatory bunch of boxes that shows off our multi-layered architecture at Microsoft. So down at the bottom, of course, you have some of those platform services in the app service dynamic runtime. So if you're familiar with app services in Azure, web apps or any kind of just generic app service, that's what an Azure function is. So we just build it right on top of that. And that's where web jobs came into play. That gives us a programming model and what we'll focus on in a minute, which is these triggers, inputs, and outputs to go with the function. On top of that is your runtimes for your web jobs and language. All right, so there's always the runtime in there and language runtime. So I'm going to do C# in here, but if you do Python instead, of course you're going to hit the Python runtime. All right, but to you, the developer, you're just going to write in C# or Python or whatever and not worry about the runtime. It's part of that platform as a service. And then on top of it, we see that the triggers, inputs, and outputs get popped up to the top where we can actually access them and our programming model. So each Azure Functions app has one or more functions. And each function with its runtime gets these 3 components to it outside of just the code. One is triggers. So each function gets a single trigger, and that trigger is the event that fires it or causes it to run. So it could be a timer. So I could say every night at midnight, run this function. Or it could be an HTTP endpoint. So maybe someone has a mobile app and they just go to an endpoint, and once that request comes in, it kicks off that single Azure function within the app. There's other triggers as well. Maybe you're going to hook up a single Azure function to an Azure queue, right? A storage queue, or a storage table, or Cosmos DB, or any of those Azure services. And we would say anytime an item is pushed onto the queue, Azure function, this particular function will run. So we can go and set up and configure, without even having to program, the fact that a single Azure function may run based off of any of these things, right? Maybe it's an item gets popped into blob storage, or a SQL table, adding a row or something like that. After we trigger the function and the function runs, during its runtime, it can access what's called input bindings. The input bindings are all of the resources that you have. So we can take bindings and we can bind this small, programming 101 block of code to maybe a SQL table, right? So maybe at a timer goes off and my function will go, it will read through a SQL table and bind to it and access that table. But it maybe also accesses blob storage as well, or a queue or something else, right? And then with output, the same kind of thing. So you can have multiple inputs. You can also have multiple outputs. So I might draw some data from that SQL table, process it, and then output it to an Oracle table, right, which is what we would do by handwriting this previously. Right? But now we can configure those two inputs and outputs, and then just write a little bit of code to actually work on the transformation of the data. But we don't have to worry about the connection strings or drivers or any of that stuff of gluing together, because we can just simply configure that in the function's runtime. So of course all that works off of the programming interface, and that is just .NET. So unless you're going to use a different language, if you're using C# or F#, it's just .NET. So the code's going to be all the same basically, right? So you could leverage those skills. You don't have to learn anything new. If you're used to Node or Python, you can just use those as you would normally. So you don't have to learn new programming languages. You can use your existing knowledge and then just learn how to configure the functions. So how this all works, so here's my favorite part. If you think about what I've been saying up to date, right? We build these apps, and often these apps that glue systems together like this, which would be those inputs and outputs, often those apps are giant things. People end up making this one big app that glues this system and that system, and you know how it is. Developers like to take something simple and make it very complex, right? And then you end up with something like that, right? What I like to do is take those big apps like that and break them down, so it's a little bit easier to deal with, right? So, if you have to get out the shovel, I think you'd rather deal with the little ones on the right than the big one on the left, because you'll be there all day doing it and tearing it apart. So if we could isolate little blocks of crappy code, it's easier to deal with them than one big giant one that we would have traditionally had. So let's take a look at these programming interfaces. So again, the trigger, input, code, and output, right? We put them all together, we get ourselves an Azure function. So let's look at what this looks like. And I'll start with the portal, and there are various ways to do it. I'll start here, but there's a few options for you that I'll talk about too. But this gives us a nice way to visualize what's happening here. So first off, maybe a little zoom. All right, so I have a function in here, and it's called raffle ticket in this case. And this would be one of those sporadic workloads. Every once in a while, I just feel like raffling off stuff, right? Just give away something. And when I do that, maybe I will allow various clients to hit an endpoint and get a number that would represent a raffle ticket. Kind of like those little tickets that you get on paper and you hand out at an event somewhere. So inside of this is a whole function app inside of here. And in it I have a few functions, including just 2 that I was playing around with yesterday in this demo. Now because this is a function app, the whole app, you see I can do things like starting and stopping it, restarting it. If you look here, you could get a publish profile to download. So if you actually wanted to, you could write your code locally and FTP it. Remember the times when we'd FTP deploy a lot of stuff? I still do. It's pretty fast and handy. But I can do that. I can set those credentials, right? So I can download the app content or delete it. Here you'll see information like the URL that I get to use, and Azure information like the service plan and the resource group. Since the service plan is here, everything in Azure needs a plan because we need to bill you somehow, right? So you get the plan. Now, if you're using Azure Functions, you have 2 choices. One is the consumption plan. You probably want that, like 90% of the time, I would say. What the consumption plan does for you is it says, hey, functions inside of this app, you will only be charged while they are executing. And that's that. Right? And this does a couple of things for us. One, it saves money. So when it's not running, you're not being billed. And that's great for sporadic workload or anything on a timer. You don't want it to be billed for 23 hours when it's, waits till the 24th to run for a few minutes. There is also the app service plan in which you get like a block of time and a fixed amount, and kind of like some cellular plans for phones, at least in the US, where you get like a block of time. If you go over it, you'll get like an overage charge. So generally, unless you know darn well exactly how much you'll spend, you probably want to go with the consumption plan. The other thing with the consumption plan that I find just kind of fun is that you'll find out who the crappy programmer is on your team, because they will literally cost you money. Right? They're writing bad code that takes too long to execute. That's going to cost more money. So now you have to at least buckle down and write some, have to think about it and write some nice code now, instead of that nonsense that I see in a lot of places. So, and I put myself in that category sometimes. Also, you get things like your subscription and resource group and all that good stuff. And here I can go to this platform features, and I get a lot of different settings here, like just general app settings for the function app. I can also do this application settings, and you know what these are. Stuff like connection strings, version numbers, those kind of things that would be in your app settings.json, or that you would normally use as just a custom app setting. Right, so I have those as well. I can get to things like networking, SSL, your custom domains. So you may have noticed back in the overview tab, every Azure Function app, and this one's called Raffle Ticket, gets a URL. All right, so in this case it'll be raffleticket.azurewebsites.net. So it's that same name, azurewebsites.net. So if I click on it, I will, yay, thank you. Right, so it's up and running. Thanks, Captain Obvious. We'll do more with the, generally you don't hit the whole app URL, but if you do, it's to see that your app is running. Look, a little winky, wasn't that cute? Do you catch that? Yeah. We're all cool, we do ASCII art. So, yeah. They paid someone to do that, Yeah, yeah, so here are my platform features. Also things like setting up some of your authentication and whatnot, and that thing everybody needs at some point, cross-origin resource sharing for my function. So if I expose some HTTP endpoints inside of this function app, and I want some other domain to access it, I need to set this up, right? If it's through a JSON call, like an AJAX call. So in this case, I do have one that I did set up, so I'll show you that a little bit later. But also, some of the actual functions stuff for Azure behind the scenes to access that. Also, you could check out your service plan and some of the other cool things like locks and diagnostics and streaming. So we get all of that in there. And some of the other development tools you might want to, these are very useful. So if I click on this kudu, you'll actually see, oh, okay, I thought it was going to make me log in for a second. I was going to say I'm already logged in. So this kudu, this gives me a few things such as information about my environment and information through a REST API, as well as a little console that I can use. And I can actually, command line and move around in directories or whatnot, or here I can actually see, since this is C#, there's IIS is going to be somewhere behind the scenes, but here I could see the individual functions and where they're hosted on my hard disk out here in Azure. You can even upload and download files and edit them right in here if you wanted to. Also, environment for old school. Right, app settings, remember this stuff from old IIS, right? All of these, for you old people out there like me, right? Yeah, so a whole bunch, like all the information that you don't ever need anymore, right? Yeah, when you do though, there it is. Once in a while you need this information, along with some other cool stuff in here, right? So you get all of this to manage your function. So, and if you go into just app services, which also it has Azure Functions in here, but also web apps and some other web apps on Windows, web apps on Linux. So there are several things that could be in here. I just have web apps and functions in here for myself. But you can see anything that's considered an app service, they're all going to have these same settings that you can get to. All right, so it's all part of the app service platform. So once I have my function app, I'll start with the single function. And this one is called Get Ticket. So I have my raffle ticket app, and I'm going to have a single function called Get Ticket. Hello, Internet. There we go. It's just taking it a second to load. There we go. So what I can do, a few things. First is I can actually write the code right here in the Azure portal, which is either awesome or horrifying, depending on which angle you take. If you are a hardcore Visual Studio person, it's probably horrifying, right? If you're amenable to, some other tools, hey, it's pretty cool. So it's up to you. There are various ways to use this. Inside of here, so I'll show you this for now, I'll show you some of the other ways later. Inside of here, stuff should be pretty familiar, such as some using statements. Now, this is slightly different, these little pound R's, and those are references. All right, so if I were to upload my own DLL, or in this case, newtonsoft.json or Azure Storage, I wanted to reference those, so I just put a little pound R in there. And I think we don't even need that for Azure Storage anymore, because I wrote that like a few versions ago. Then inside of here, if you look at is just .NET code, and being that this is just a raffle ticket, I made a random number, so it's not it's not even fancy code, it's very simple. Inside of here, I'm taking a random number and I'm adding it to a collection of tickets. Now these tickets, to get your little raffle ticket and the number, I'm going to store in an Azure storage table. Now the cool thing about Azure Storage Table is being that it's built into Azure. I don't have to do any kind of fancy anything to get it to happen. All I need to do is write this code and say I'm going to add a ticket. And I'll show you this integrate tab in a second where I actually configure that. And it will automatically create the Azure Storage Table for me and create the connection string for me. I don't have to do any of that, which is nice. It's like magic, right? I like that. And of course, you don't have to deal with connection strings, which is pretty awesome. So in here, I'm just going and adding a new instance of a ticket, and because it's an Azure storage table, I give it some of the keys that it's looking for, and my own little pieces of information like that number, the date, and if this has already been selected as a winner or not to go in there. Once I create that little ticket with the number, I am then creating an HTTP response. Remember system.net.http create response, something like that. I forget the exact namespace. That's what that is. It's the same .NET code that you wrote literally like 10 years ago, if you were writing .NET back then. So that's all I'm doing is creating that HTTP response with a nice little status code and returning that random number. Now, when I am using these, right, of course we'll have my function, right, the heart of this. Now notice what is not here in between the using and this function. There's no class in here. Yeah, that's interesting, that's weird. Interesting, weird, yeah. Right, so there's no class. I could put a class in there, that's fine, but it's kind of not the point. We only really need to get to the function. And you know what .NET is doing, right? They're being sneaky, not sneaky because I know what they're doing. They're just putting a class in there anyway, right? They're just wrapping that behind the scenes for you, right? So that's all that is. There's a class in there, you don't need it, not for the purposes here. If you put it in, it's not a big deal. And in here, so your function name is always going to be run. Right? So I have this, well, not run, let me back up a second. My function name is getTicket, but in the code, we just say run. Right? So getTicket as far as we're concerned, but when it comes to programming, we just call it run. Async, of course, you don't have to do async, but it is a first-class operation in functions, and it's generally better. So in here, because this is going to come in from an HTTP endpoint, I do get an HTTP request that I get to work with. All right, so I get that. Every function gets a trace writer. You just get that for free. Whether you like it or not, you're getting a trace writer. And with this, you could log. You could do a log.info, and you can instrument what's going on. Since I'm using Azure Storage Tables, I have a few different types I can use, and in this case I used one called an iCollector for the ticket, and I made my own little type just called ticket, and it has the date, the ticket number, and if it was selected. Now I took that little ticket, and it's just down here in a class, right, that inherits from table entity, and that's specifically for Azure Storage. If it was Oracle, you might have a class just to do a POCO, but you wouldn't necessarily have to inherit from table entity, right? Just do that for like Oracle or SQL or something like that. Now, in an actual real-world scenario, I might take this class and move it to its own little file. That's fine. But so that I'm not clicking around in a web browser, I just put it at the end here. Makes it a little easier to show how Azure Functions work. Now at any time, I'll unzoom a little bit here. At any time, I'm writing my code, I want to test, I can come over here to the right and I can expand my little test area. Now here's all of the hard stuff behind functions. It's the run file, .csx, or .cs is fine, either or. We'll see CS in Visual Studio. And then function.json, which I'll show you more of in a minute. That is all of the files you need for the Azure function. So you can do this 100% in Notepad if you hate IntelliSense and color coding. If that's how you roll, knock yourself out. But that's all you need. Now, if I were to do this, get a little raffle ticket in a Visual Studio app, the smallest app would be a console app, but if I wanted to do it on the web to expose an endpoint, there would be more. I would still need the project and the solution and having to build it and all of that stuff. Well, here, this is all I need. So if I write these in Notepad, I could take them and FTP them into the function, or just, upload them through Kudu. So all of that, I already said before about like having a clear path from the sysadmin and the IT pro side of things and the platform, but also sometimes Visual Studio, for as great of a tool it is, it gets in the way sometimes. Sometimes you only need a couple of files to run something. And sometimes it's just those couple of files put into a microservice architecture that work together in sync. But often the project and the solution and then all the other stuff that goes with it kind of gets in the way. Right? Sometimes it doesn't. Sometimes it helps. So I have these, and here I could actually add an upload here. If I want to test, I could just come here, and if I need to, because I'm using endpoints, I could put stuff in the headers or the request body or any of that. I don't necessarily need that here. So I could click run, either run that I want. And when I do that, here I'll see it actually gives me, there's my little piece of data back, and also I like how it's telling me like, oh, no activity. No, it tells me that there's no traces until I'm ready, and then function started, stuff, function completed, and in here I did have a log.info, and that's printing this out right here, this little ticket number. Right. Now, if I want to test this another way, I can go to the functions URL, not the whole app, but this individual get ticket function. So if I come up here at the top, I'll see this little get function URL link. I can just grab it, copy it, and you'll see I also have some keys I can use. So I set this up for just anonymous authentication, but if you said you could set it up to have to pass in an API key or stuff like that, along with HTTPS or any of that security as well. So in this case, I'm just going anon to make it nice and easy. If I just come in here and paste that URL in, see I get a piece of JSON back, and that was from that response that I've created, right? And down here at the end of the function. Right? So that's pretty handy, right? So it does exactly what it said, right? It just takes some input, and that would be also in this case the trigger, which is that HTTP endpoint, does a little thing and returns a piece of JSON in this case. All right, so it just does that nice little small execution. Now in this case it's a very simple example, but if you think about all of these little things that you need to glue parts of your business together, I can have an app with many of these that are, running back and forth all of the time, maybe through an endpoint or maybe in a different way. So let's look at some of these other options that we have. Well, we're still in the portal. If I wanted to add another function to this app, I can do that. And I can do that by clicking this little plus sign in here. Also, if I'm using like Visual Studio or even Notepad, I can just make a .csx file. That's fine. Here I can see all of my different languages available. Right? Even TypeScript is in here now, PowerShell and PHP. I forgot about those. Didn't get those on the slide. So that's TypeScript is a little newer. So I could pick languages that I want to use in different scenarios. Like are we doing data processing, which would be some of these popular items, or maybe IoT stuff, or any of it. So let's look at all. And here I could see, when I do this, this is like the file new template for an Azure function, for an individual function, not the whole app. And in this case, here I could do the same thing, an HTTP trigger. But instead I could do a timer or a queue. So if I did a queue, anytime an item gets pushed onto the queue, this individual function would run. Or service bus queue. Blobs, service bus topics, generic webhooks, Here's another fun one. GitHub comments. Yeah, that doesn't nag you enough. You want more of that. Let's see. HTTP, get and post. Or you could just go generic and not specify. Scheduled mail. Image resizing. So if someone uploads an image, apparently this is all the rage now, just taking images and resizing them. But I've seen, I don't know how many companies that have maybe a public-facing website, and you have an image and a thumbnail, or multiple sizes for mobile apps versus a desktop app, and they need to constantly resize their images. And this is perfect for that kind of stuff if you have to help manage public website. Also things like SendGrid, so if an email comes in, or the new Face API. Right, so you can actually do the facial recognition. So any of these things that you have, App Insights, external files. So I could say, hey, whenever a CSV file, here's something that's popular. Maybe one of your partners, vendors, or customers. Maybe a customer makes up a batch of orders and uploads them via FTP, that was one too many T's in there, FTP, to some location. So some location that your admin had carved out for them. They drop off that file maybe once a week or a few times during the week. And when that file gets dropped off at that physical directory, you have some software running monitoring that directory. And when the file gets dropped off, that would launch other software to take that file and process it. Maybe take a CSV file and process it through, put it into SQL. Right? I see that everywhere. Right? That's a very popular thing to do. So maybe, yeah, even with FTP, but it could be through other means too. Maybe they are emailing it to you, or whatever it is, or just emailing an order. Right? So external file and external table. External tables give you Oracle, like Sybase, Dynamics CRM. There's like a whole bunch of stuff in the externals that you can get to. So all of those file formats that you would work with other companies perhaps. Even Cosmos DB and event grids. Right? So all these things, any of these things can trigger an Azure function. And we're adding more each day. So as you see, you get this buffet of services that you could say, whenever something is happening here, and items are added or deleted or whatever is going on, that's going to make my Azure function run, a particular function inside of an app. So maybe I'll just go with the simple timer one. And if I do that, of course, I would give my function a name. And since it's a timer, I would actually give it a schedule. And in this case, it uses a cron expression. So that comes from Linux land, because again, we love Linux. So we needed to swipe that. If I did maybe instead a blob, just so we could see what it might look like. Instead, if it were, say, a blob, I would give the path to the blob. And it would actually create the blob for me if there wasn't one created to work with. And then my storage account and the connection string. So I just pick those out and run with them. So, you know, whatever thing I pick here, you'll see some different options to configure. Once I go ahead and do that, and I figure out what it is I want to do, like say a timer, and I click create, it's going to create that new function for me. So in this case, it's that third timer trigger. It adds in a little bit of code for me. And in this case, since it's a timer, it's pretty apt that it would actually give me the timer to work with, and of course my trace writer. And then I could come in here and write more code to do whatever it is that I need to do. Now the whatever I need to do, other than just regular old code. Let's go back to our get ticket here. I'll click on this integrate tab, and here's where a lot of the magic happens. But it looks weird in Zoom, so there, that's a little better. Even though it's only 100%, I hope people could see. I don't know, my glasses get thicker every year, so I have to keep upping the zoom on the browser. Old people problems. So here, I see that trigger over on the left, right? One and only trigger. And in this case, for my ticket, it's that HTTP endpoint. And here, I could see that, yes, I want all the methods. But if I didn't, I could pick them out here. All right. No, I'll just keep them all. That's fine. Then I have my request parameter name, REQ. If I go back to the code and I look here in the code, that is indeed what it's called, REQ. Right? So what's in the integrate tab ends up as a parameter for the inputs anyway, as a parameter inside of the run as part of the method signature. All right, so if I come back here to my integrate tab, there it is. And then also if I wanted to, it's ASP.NET running in the background, so I could set up a route template and also some auth as well. Now for any of these things, these triggers, inputs or outputs, down at the bottom you'll see this tiny documentation link. If you expand it, you will see all of the things that are available for this particular item that you're working with, as well as some code samples. So it's really handy. You don't even have to open another web page. I have no other inputs for this, just the trigger, which in this case, because it's in the method signature, it kind of behaves like an input. But the outputs, one of them, I can have multiple ones, and I just have a kind of a default return. I don't care about that though. What I want is the Azure table storage. That default return is just the response that I'm creating, that piece of JSON. We saw that in the code. Here, the Azure table storage, and it's called tickets, little t tickets. So here in the code, again, the parameter name for the code, and it's tickets with a little t. If I look over here on the right side, I get this table name, and it's tickets capital T. Now that's the actual name of the storage table in Azure behind the scenes. So if I didn't have that, the first time I run it will actually create that. But if I look for the little t tickets and I go back to the code and I look in my method signature, it is indeed there. And I used an iCollector type for that. So if I pop back to my output and I look at it, right, there's my tickets. Now in the documentation, that's where it tells us, here's what I could use. Right, I could use an iCollector, I could use an iAsync collector. I actually should have used that one since I was doing it, started async. And you want to inherit from a table entity because it's Azure storage. If I was using a queue, I might have a little different technique to use here or type. And of course, I also get it creates all the account names and the connection strings for you. So you can actually use those in the code, but you generally don't need to, right? It's just available. Then here, of course, where I'm actually storing that, right? Where my storage table lives, what storage account. So I have those set up. So I have that code, but here's my triggers, inputs, and outputs, that trifecta of glue to glue these things together. Now I could sit here and point and click like I've been showing you, or I could go to the super advanced, really secret editor that has this link right here. And yeah, I lied, it's not really that advanced. It's just JSON. So as I'm pointing and clicking, it's taking those triggers, inputs, and outputs, and it's just creating that JSON file. And it's that function.json that I showed you before. Right? So you have the choice. You can point and click in the portal. That's great. You can actually come right in here and type in the JSON yourself. That's great. You can do it in Visual Studio and upload it, or VS Code or Notepad, and it's just a JSON file. So you get the JSON one way or another, as long as you have the JSON to say, here's my inputs and my outputs and my trigger. And you could pop back and forth wherever you like to write that code. And it's up to you entirely. So we have our function, our inputs, outputs, and triggers, and that's what makes one single function inside of the function app work. Other functions, of course, are going to behave in the same manner. It's just a matter of picking from the integration what it is that you want. And if I come down here to the second function in my app, the select winners, right? So once I get a whole bunch of tickets, which before I go to the select winners, when I get tickets, so far I've just run it here to see the JSON return. But you probably, something like this with an HTTP endpoint, you would probably hit it with an AJAX call. So I actually have a little domain called Azure Raffle, and it's an Azure website with 2 HTML pages. One is to get a ticket and the other's for the winners. So that's all it is, just a static website. This could be a mobile app, it doesn't matter. And so I have this HTML page. And then I can come here and click it, and I get that. All right, so I get a ticket this way. If I view source, hey. There we go. If I view the page source, this should not be a surprise to anybody, right? It's just an AJAX call, right? HTTP request, right? And here I'm just getting the response and cramming it in a little div or a span, right? That's it. Yeah, not much going on here. You're very anticlimactic, right? So just a JSON call, right? Just an AJAX call. That's perfectly fine because I'm just giving it back AJAX. Now these HTTP endpoints are very popular, so that's why I have them as a demo. But the timer trigger is also very popular, as well as all these other events. So it doesn't have to come in from HTTP. It could come in from another manner as well. Now, some of these inputs and outputs, let's go back to the select winners now that I've showed the ticket. So here in the select winners, it's very similar. Again, an HTTP endpoint. So if I run this, it should show up and give me a list of several winners. So it runs through and it just grabs every like 20th row or something like that, and then just sticks them in a list and gives back a list of JSON. So it's doing a very similar thing to the other one. You can have them doing wildly different things. Your grouping for the functions inside of an app is just going to be logical, like maybe all the ones that work with customer data or all the functions that work with accounting data. So the organization is kind of up to you. In this case, it's everything to do with the raffle ticket. In this case, I'm taking inputs and outputs. Now this is how we get one function to call another. Generally, in regular old programming, any old language, you have a function, and it might actually call another function. That function runs, returns a value back to that first block of code. Right? That's pretty standard. You can do that here, but then you're just going back to regular programming and not integrating systems together. So what we could do, a much fancier way to be able to get functions to call another one and participate in systems integration is again with these inputs and outputs. So instead of my tickets, and you see another thing too here is the get ticket tends to run separately and on its own from the select winners. But yet they need those same resources. So instead of one calling another, what I could do here is with my select winners, I could set up the input, and that input is that same storage table. In here I just used a different variable name. I just used a capital T, but also for the table name, right, just to show you can do that. So I'm accessing it. So in the create ticket or the get ticket, I'm filling up the table and adding rows to the table. Then later on, when I decide to select winners, I'm going through that table and accessing it. Right? So I'm writing it here and then reading it there. Once I do that, I'm doing the same thing for an output here, but I'm just marking them as whether or not it was a winner. All right, so I'm just scrolling through the table. And this is often the kind of stuff that happens in enterprises, right? We need to go through one table, flip some switches or some fields, and then pass it off to something else that picks up and carries the torch. All right, so that's what we're doing here. So the code is going to be very, very similar. And so in here, of course, I'm going to have, I could have an endpoint, but I could set this up maybe instead to run on a timer and just, select winners every Friday instead. Doesn't matter. In this case, because I'm using a table for input and output, here I see I do have an iQueryable to go through and grab those winners from the table, and the iCollector to mark them if they are a winner. Other than that, it's just standard old code that just does a for each through the table, right? So there's nothing fancy in there, just regular old .NET code where I'm setting that ticket up. Then I do my little bit of logging, and I return a response with the list of winners. But you see how I was able to stitch these together by those access points, and those access points are the inputs and outputs, right? So in this case, it's all Azure Storage tables, but it could be a queue instead, or blob storage, or Cosmos DB, or a text file, or anything that you need it to be, right? So that gives us some really cool benefits there. Let's see, what else do we have? There's a Manage tab. Yeah, it just has stuff like if you need to enable, disable, or delete, and managing some of your keys. You can also get to these through the function apps properties as well. Now if we go on to, like, say, tooling. Yes, I talked about all of that other stuff here. Let's see. So tools, Visual Studio, and VS Code. If you don't like going into the Azure portal, that's cool. Right? And a lot of us spend a lot of time in Visual Studio. So in here, if I wanted to create a function app, I can do a File, New Project. And then in here, I will pick Cloud and then Azure Functions. So I have my Azure Function app. And then I could click OK. Now your Azure Function app, the whole app itself, does have to have a unique name. And I'm pretty sure Function App 4 is probably not unique. But when I go to deploy, Azure will figure that out and tell me, like, hey, that's not unique. Pick out something else. That's fine. Just to show you how this works, Function App 4 will work. As you see, you don't get a whole bunch of stuff like you might in a regular Visual Studio project. File, New Project, like 10 minutes later, you're like, will you build the assets already? Right, and then you get a whole list of all the packages and everything else and a whole big old template. Nope, we're going small. Right? Remember, all we need is the CSX and the JSON file for an Azure function. So my app, in this case, we're going to get a proj and a solution because Visual Studio needs them. Visual Studio just does not know what to do without, they tried it and it went down in flames. You should have been there in the meetings. Woohoo, that was fun. But yeah, like Visual Studio just has a hard time with handling things that are not necessarily in a solution and project, at least at this point in time. So once I have my function app and I do have my solution and project, I could go to my project and do the right-click, add, new item. And as you might expect, there's an Azure function in here. So I can take my Azure function and click add. And then look at all the stuff that you saw in the portal, and those lovely little squares where you could pick stuff out and point and click. That's all in here. So the timer with the cron schedule. Or, queue. Well, now you have to actually type in your connection rather than pointing and clicking. And then whatever path. And you can actually usually get these connections if you already have a queue right out of the portal anyway. I could do my webhooks, which is just an HTTP endpoint as well. Or, trigger, so I could do the same thing again. So I get several of these same options, right? So I just come in here, pick what I want, I pick OK, and then here you'll see the class, but Visual Studio kind of needs that. It gets upset when you don't put this in here. Watch how upset it gets. Look at little red squiggles, and then if I try to build this, it might yell. Unless it got smart, really. Ooh, really? Yeah, it's going to yell. Oh, there it goes. Right, like, what are you doing? Yes, all right. So the class is there, either there for Visual Studio's benefit, or, it just gets wrapped up and removed in functions. Like I said before, that doesn't really matter. But here you'll see the only difference is with the tooling, because they're building the portal and the tooling kind of parallel. You'll sometimes see little cool things that pop up in the tooling that are not in the portal. Sometimes you'll see cool things in the portal that are not in the tooling. It's just, different teams work on this stuff. But here you'll see the same thing of run. But in this case, you get a cool little function name as well. So you don't have to just deal with a whole bunch of functions called run. Also, the compiler could use this, right? So it doesn't see many things called run. And then, of course, a little bit more on the attributes side, which are very handy, but you'll still see things like your trace writer and your inputs and other stuff that you need. And here's like that same little bit of template code that you would get if you did it online. And if I look over here, in this case they didn't put an X on the end of it, but it's going to end up being that same file, right? Once you deploy to Azure, it'll look like a CSX. It's just a C# file. And then you'll see you do have the JSON files in here as well. All right, so that's really, again, all you need. But now you get tooling, you get IntelliSense, and all of that good stuff to be able to create your function. And also, now I'll run it, but it's going to bomb because I tend to get some of the nightly builds and they broke something on me. I think they did it on purpose because they knew I was at a conference, but that's just my opinion of how the team abuses me personally. So, but I run it ASCII art because we're cool now. Okay. And here you can actually see it gives you that little endpoint, right, with your local host, but you'll see API and then the function name. So before, when I went into Chrome, oh, that should have bombed already. I'm doing good so far. Right, but if you see that had the API and then the name of the individual function, right? So you'll see that here, but locally. I bet if I try to actually do anything, it would yell. Let's see. We're on 7071. Forget typing. Let's just copy and paste. Also, why Stack Overflow exists. Yeah, I was going to say I didn't have, well, no, style information is not necessarily an error, but I knew it was going to do this stuff from some other things that need to get fixed in my build. If you do get errors, you will see red stuff, but as you see, you could do debugging, right, when you don't have things slightly broken from the build from last night. So you can actually go step through the code and do stuff locally here. Really, the only testing that you get out of the portal is just coming here and doing the little run. You can do the run here and see what's happening in the trace output. And of course, you could get like Postman or F12 tools or any of that stuff is fine. And you can just run it through the browser as another way to just test that the inputs and outputs are running. But if you need to step through it, if you have some significant amount of code and you want the debugger, you can do it in Visual Studio. So if you get the tools, and this is 2017, so if you get the tools, your debugger should be fine because the stuff I have on here isn't quite released yet. To get the tools, when you install VS 2017, you'll see, and there's an external thing for 2015 that I cannot guarantee will still work, so there's that. But in 2017, when you install, a big page pops up and it asks what you want to install. And one of the big blocks is, Azure and cloud development. So you just grab that and function tools will just show up in there. So you'll have them. But if you want to double check, you can go to tools and then extensions and updates. And then in here, a dialog should show, there it is. Like something should show up. You'll see Azure Functions and WebJobs tools. All right, so if you have the Azure tools installed, you should see this in here. And then that means that, yes, indeed, you can get to Azure Functions on that. VS Code, you could just write in VS Code and upload, right? So you don't really get any specific tools per se. There is a little extension for Azure Functions. It does a few things for you, but like the heavy hitter is right there in Visual Studio. There's also a separate tool if you happen to be using Azure Storage specifically. If you're using some of the other services, there might be external tools for those. And there's an Azure Storage Explorer. That just lets you actually look at the stuff in Azure Storage. So it's not functions specifically, but often Azure Storage is something used with them. I run right to Azure Storage anymore instead of SQL. It's so much easier because you don't have to set up connection strings. You don't have to do anything. That's just going to take a while to load. But you can just drill down and find whatever you're using, as long as it doesn't make me log in. There's my raffle ticket. So I could come in here and look at my, it's either a blob or a table. There we go. Yes, I know. Later. Thanks. Only wants to update when I'm showing people stuff. Yeah, but here's that table, and I keep adding tickets to it. So I can actually go and see if I'm using a storage. So that's a separate tool that's very handy in the land of functions as well. For things like scaling, so what you want to do is, of course, keeping it stateless. Try not to be doing things like the traditional approach to programming where you cram a lot of things in session, even though you know you shouldn't because it's the dirty thing to do. Try to avoid those. Avoid long-running functions. Again, you know, if you were the bad programmer, you're going to out yourself really fast when you're costing the company money on the consumption plan. Queues are a really good friend of yours if you're not using storage tables, because queues are a great way to pop an item onto something temporarily and then push it on and pop it off later. And of course, don't forget your exception management, of which I have none because I'm the bad practice developer. All right. Yeah, yes, I'm that developer. Small, fast-running stuff. Asynchronous is generally better. And you want to watch, you can share, memory shared between functions. So some things you could do, just so you're aware, because memory shared. I can come up here at the top by my references, and I could do a pound load, and then point to a .csx, and just start calling code out of there. But don't, that's kind of just regular old code. You're back to just a plain old console app in the cloud. Let the inputs and outputs be the glue, rather than calling directly to another function. And even though I have a run here, I could still actually have a method called, you know, like do stuff that is also in this file. That is okay, if it makes sense. Sometimes it'll just be the run, but once in a while you may have like actual 2 or 3 functions in there. That's okay. Just make sure that you don't go crazy. Anything that's a best practice for app services is a best practice for functions in general, because it is sitting on the app service platform. Watch your disk operations, however, even though that's technically a functions best practice, too many companies have to access CSV files, so you don't have a choice very often, right? But of course, we would love it if you would just take those files and convert them all to Azure Storage Tables or blobs or something else, anyway, or Cosmos DB, right? Any of that stuff would be awesome. So, as far as settings and deployment, look, the old portal. They used to look like that. I should take this out because every time I change the slide, they change the portal. I think they do it on purpose, just to get me, right? So there are some things you could do if you're deploying, well, several ways. One is if you're in Visual Studio, because it's just an app service, you could do the publish, and then just Azure Function App, click publish and pick out my app name, my subscription, resource group, service plan, all of those things that you would point and click at in the portal. All right, so all of that you can deploy here. I won't deploy this one, but just picking out stuff out of the list of where it needs to go. All right, so you can do that with Visual Studio. That's fine. You can also FTP the stuff right up. If you get your published profile, that little URL out of the settings, that's another way. A third way, here's something you'll probably want to look into at some point, and especially if you're a Notepad person, you'll love this. Even VS Code, there's something called the Azure CLI. Right? So CLI for command line interface, and we're up to version 2. And I'll go right here to the reference. I hang out in here a lot. I love these pages. And you don't even have to hang out here. You could just work this from the command line, which is nice since the web page doesn't seem to want to come up. All right. So if I go to the command line, so if I do something like AZ function app, help, might take a second. But you'll see a whole bunch of these command line, well, that was internet lag right there, like the internet took a nap on us. All right, so you'll see all these commands and they start with AZ, right? And it's everything, not just functions. Functions are in here, but like AZACR for Azure Container, App Service, Cloud CDNs, consumption plans, Cosmos, like everything Azure. Eventgrid, here's our function apps are in here. Web apps way at the bottom, way at the, there it is. Web apps as well. So anything you could do in Azure, not just functions, has this command line interface. So I can go to any of these and I could start saying they all have the same pattern too. So we are very consistent about this. And I could say, look, I want to maybe take this CSX file and my JSON and just push it to the cloud from the command line. Maybe I want to create my function app that way. So I could do that. So if I did my AZ function app, I could do AZ function app create or delete or list. So if I did AZ function app, I do have to spell it right, list, that should give me a list of all my function apps. Stuff, and it gives it to you in JSON. If you don't like JSON, that's great. I could say output table, and it'll give it to me in a table. And in a small command line, sometimes that's a little hard to read. But here, my whole function app in that particular subscription, my raffle ticket, and here it tells me my host name and all of that good stuff, right? All the same stuff that's here. And I can do this for anything from web apps to functions to container registries. So all of that is available. I could do all my config with it. So you could put this in a little batch file and just run it if you need to and upload those files that way. So you have all these choices, right? Portal, Visual Studio, Azure Command Line, various ways to be able to get the code up into the cloud pretty easily. So that's up to you. Something else you can also do is you can set this up for continuous integration and integration with GitHub. So if I go to my actual function properties, these platform features, in here, and this is any app service, not just Azure Functions. So if I come in here and I go to code deployment, you'll see deployment options and deployment credentials. If I go into deployment credentials first, here is where you set up a single deployment user for all of your app services. So any app service I look at will show the same username, and then I can reset the password here. Right? It will keep that same password that I already have until I change it, but I could reset it. So once I know what this deployment user is, or once I set it, if you don't set it, Azure gives you like a very cryptic username and password. So once I have that deployment credential set, and these are the same creds that you would use for FTP. So if you use like FileZilla or something, you can just go into FileZilla and give it this name and password and FTP it. Once I have those creds, I could go to deployment options, and then I could use it if I need to. One of the things I could do in here is set up a deployment. And when I do this, I could go to the deployment options. Now, I can also do this with the Azure command line. right? I could do AZ set deployment user would also do this. But here I could choose the source. I love that OneDrive is in here. That makes me laugh. Who else deploying the OneDrive? Like literally nobody ever. Any talk, like no hands ever. Right? But yeah, or Dropbox or whatever. External repo maybe, but usually it's Git or team services if you have to, right? But did I say that out loud? That's our stuff. I'm not supposed to do that. But you just come in here and point and click and grab your GitHub source. So if I have a repo, I could pick out exactly which repo, my cool test repo, whatever, and the branch, and then tell it OK. Once you do that, though, it will not allow you to edit this in the portal anymore. So I will not click OK here, because I want to show this portal to other people, right? So, but then you would see a little bar will say, no, you can't edit here. You have to edit and then push to your Git repo, and it will automatically sync everything, right? So if you're just using Visual Studio, you can do the little commit right out of Visual Studio. Apparently this code doesn't want to load, but okay, whatever. Oh, there it goes. But so if you're using GitHub, all right, so this way you don't have to push to GitHub separately. Just push to Git, and it will automatically sync. And it does that with any app service. I just set up one yesterday. I think maybe it was one of these. Let's try the Ruby. I think I actually did it with Ruby yesterday in one of the talks. But you'll see the deployment deployment options. And then as you actually make commits to Git, yeah, this one has it because it's taking a while to load. You'll actually see all the commit logs in here, like that you committed to Git, right? So that would show up. Sometimes it takes a while, though. Cloud is sometimes very slow and foggy. But you get that available. So that's kind of nice because we like to just push the code, and you don't have to hand synchronize it. It just let the tools do it for you. So that's just going to take a while to show up. So did that yesterday. Any app service you could do that with, not just functions. Anything that's an app service it works with. All right. Same deployment user. All right. Anything else? I think that's basically it. Yeah. So you could set up all that stuff to push. And then there's a little bit about, you can actually share your libraries. Again, if you have a DLL, you can just upload it. Generally, if I'm going to do that, inside of the function app, I make one function just to put those in, and then I could share it. Remember, the memory space is shared between them. So I would have a little function I would just call shared, right? And then just put anything shared in there that you want. Right? And there's a little how-to, so you can hurry up and memorize that. Yeah. I have this PowerPoint out on the web. You can dig it up and get the link. So that's pretty much all I have. I think I went 2 hours or maybe more or something. So, yeah. So at least I stopped talking at some point. Sometimes I don't. So, yeah. Yes, you know that too well. So that's pretty much all I got. Thanks for listening tonight and hosting me here. So I hope this will benefit. I think I'm seeing some smiles out there. It looks like this will benefit a lot of people, being able to use Azure Functions in your projects. So hopefully it will. And if you have any questions or anything, I'm pretty easy to find out on the internet. There's not a whole lot of Rachel Appels at Microsoft, as far as I know. No other imposters. So you can find me pretty easy, or just Rachel AP at Microsoft. And I'm out there. I'm also on Twitter and all that good stuff. So thanks.